to. So for 8.6 and 8.3, this first part is 8.3, we are going to talk about the relationship between perimeter and area for right now, and the scale factor. So right here I have a rectangle. I'm just going to call it O for original. I have this rectangle, and then these are similar rectangles, which means same shape, but just different sizes, right? So this one's twice as big on the dimensions, 6 and 8. This one's half as big. We'll call this one the first one. This one we'll call it figure 2. And then this one is 3 times as big as the original one. Okay? So the original one, Amanda, what is the perimeter of the original one? Yeah. So we think in perimeter and area. I'll add the sides all together, yeah.
14.
14. Okay. Madison, what's the area of the original one? 12. 12. Okay. What's the perimeter of the first one? 28. And look, what's the area of this one? Okay, so figure number 2. And what's the perimeter?
7.
7. And what's the area? 3. Okay, and then for the big one, I'm going to have to grab your calculator. Cassie, what's the perimeter of the big one? 42. Okay. Someone have the area? 108. Alright. So the scale factor, now you can do scale factors as either a ratio, as like if I have 3 to 2 would be a scale factor, or you could do it as like a fraction, like 3 over 2. And this would be the first one to the second one. So right here when I say the scale factor of the first one to the original one, that means the first one goes on the left, if I'm doing it with the colon. So as I look at the first one, it's 28. Oh, sorry, I'm just going to look at the numbers. The first one I'm going to say, I can either use, I just have to do the sides that go together. Here's 6 and 3. So you'll want to simplify it. So you would get the scale factor is 2 to 1. So this first one, scale factor 2 to 1. Looking at the perimeters of the first one to the original, what's the ratio of the perimeter to the original one? 2 to 1. Again, 28 to 14. So 2 to 1. But what about the areas of the first one to the original one? 4 to 1, 48 to 12, which is 4 to 1. Okay? And then we need to do that with the original one to 2 and to 3. So the original one to 2, the scale factor is, well, let's just look at this one we do here. This one to this one. So 2 to 4, 4, 1 to 2. The perimeters, looking at 7 to 14. Right? 1 to 2. And what about the areas? 3 to 12. 1 to 4. Okay, this one. Scale factor. When you look at 9 to 3. And just make sure we do the right way first. It's saying the third one to the original, so we got to do 9 first. So 9 to 3. 3 to 1. Perimeter. 3 to 1. Area, what about 108 and 12? What does that simplify to? 9 to 1. And these ones happen to be all to 1 somewhere just because they were like doubled or tripled. If I did one this would be 4.5 to 6. Okay, so if I look at a fourth one, we'll call this one number 4. What's the perimeter of the fourth one? 21. And what's the area? What's 6 times 4.5? 27. Okay, and then what about if I do number 4 to the original? So I have to do 6 goes with 4, right? So this reduces to 3 to 2. So right here, this is going to be 3 to 2. What about the perimeters? 21 to 14, 3 to 2 still? Okay, the areas, we've got, what is 27 to 12? 9 to 4? Alright, so the scale factor, what do you guys notice about the scale factor and these other ratios? Scale factor and the ratio of the perimeters? Same. What about the scale factor and the ratio of the areas? Yeah, this one was, it was kind of hard to see on the first ones, but notice 3 to 2, square 3, square 2, you get -4. So that is something that you guys need to know and use. You have, if you have two similar triangles, so they have to be similar figures, and this is the scale factor. The ratio of the perimeters is exactly the same, but the ratio of the areas is a squared over b squared. Yeah.
What was the ratios of the fourth one?
So on this one, it tells you that the trapezoids are similar. So I mean, if you didn't know that, you could probably look through necessarily, but it says they're similar. The ratio of the corresponding sides is 6 to 9, or simplifies to 2 to 3. If you want to know the ratio of the perimeters, now be thinking one dimension is just like to the first power. Kind of think of it like that too. So the perimeters is going to be, the ratio of the perimeters would be 2 to 3. And we don't know what the perimeters are, but we know that the ratio would be 2 to 3. And the ratio of the areas would be 2 squared over 3 squared, or 4 over 9. So if I knew what this one was, which we're going to do in a minute, something like that, if I knew what one of these was, I would be able to find the other one. Because this one would be 4/9 the size of this one. And you need to set up a proportion. It's going to be a lot of proportions today to solve.
In the fraction ratio, you'll always see it in the fraction, right? You want to understand.
Either way really works. But if you do it as a decimal, then it would be more like, if you did the decimal, it would be like 0.44, and you'd still have to say like 1. So you could do it, but it would just, you got to be thinking that this is 1, this is the other one. But most of the time we do everything, we're just going to leave it as a fraction because it's going to be more accurate here. Alright, so what I want you guys to try is, everyone on your whiteboard, do these 2 questions. It gives you that they're similar. You know the lengths of the sides. I need to know the ratio of the perimeters and the ratio of the areas. So write on your whiteboard 1, write the answer for both of them. First do perimeters, then areas. 2, then do perimeter and areas. Did you get it? Okay, so the thing I want to make sure I point out to you guys is you do the first, you have to read what it says. If it doesn't say anything, probably just do the one to the left or the one on the right. It'll, okay, quiet. It'll usually say say first figure to second figure or big one to small one. It will tell you something like that. So if I look at this one, the scale factor of these is going to be first figure to second figure is that. So the ratio of the two things, so the scale factor. So this simplifies to 2 to 3. So this is the scale factor. But whatever the scale factor, the ratio of the perimeters is exactly the same. So it's just 2 to 3. And the ratio of the areas is you square the 2 and you square the 3 to get 1x. So that was what that one was. Yeah.
When would the scale factor be different from the ratio of
The scale factor and the ratio of the perimeter will always be the same.
Okay.
Yep. So this one was 3 to 5. So this is the scale factor and the ratio of the perimeters. And then of course squaring that 9 to 25 is the ratio of the areas. What we're going to do now is if we know the two polygons are similar, if we know the area of one and the scale factor, then we can find the area of the other one. So this one, this is saying this is 4 centimeters, this is 10 centimeters. So what's the scale factor of this? And I want to do, well, I guess it doesn't matter if I do bigger or smaller, this is what we're doing. So I'm going to do what? The smallest to the biggest, is that good? So 4 to 10 or 2 to 5. So that's the scale factor. So if I wanted to know the perimeters, and if these, well, these are regular polygons, so they all have 4 all the way around. If you checked it out and you added up the perimeters would also have a ratio of 2 to 5. So this question is saying the area of the smaller one is 27.5. And it wants to know what the area of the bigger one is. So, if this is the scale factor, what is the ratio of the areas? 4 to 25, square both of them. So you know that 4 to 25 right here is the ratio of the areas. And then you've just got to make sure if it says the small one is 27.5, you've just got to set up your proportion. So the 27.5 goes with the smaller number. 4 is a smaller number, so it goes on top. And then you put the other number on bottom. And then however you want to solve your proportion, this one says cross multiply. 4 times A equals 27.5 times 25. Divide by 4. So this is the area of the bigger pentagon. And when you get done, you should always look at it and see if it makes sense. Because if the smaller one is 27.5 and you get the area of the bigger one to be smaller than the smaller one, that doesn't make sense. So even if I'm doing multiple choice, before I do anything, I know that one's not right. So it can't be smaller. So of course this one, that was the answer. So I want you guys to do do 3, and if you get 3 done, well, don't do 4 because 4 is, if you get 3 done, then do this dotted one right here. But do 3, that's the one I want you to do right now. This is, they're similar, 12 and 18. The area of the larger one, so make sure you look and see which one, if it's larger or smaller, is 121. Find the area of the smaller one to the nearest whole number. I didn't have that one, so I didn't do the dotted one. I forgot to copy that one over. Yep. So the scale factor is 2 to 3, right? So don't forget that you don't use the 2 to 3, that you have to square them because you're dealing with the area. So 4 to 9. Make sure that you put the larger one on with the 9. So when you solve that, and just be careful that you follow instructions. It says what is the area to the nearest whole number. 54 is the nearest whole number. It doesn't say what's the area in meters squared. So technically you should put 54 meters squared for your answer to answered the question. So this one, I'm just going to walk through. It has the area. This has a high school group. They planted some bushels of vegetables, and whatever they planted, the city gave to them. They got 13 bushels of vegetables. We don't know exactly what the area was, but we know that the city's going to let them use a large similar plot where each dimension is 2.5 times the original one. So it does have to work. In order to be similar and for this to work, it has to go, if this is right here, it can't just go 2.5 in one direction because it's going to be 2.5 in both directions. So this isn't exactly what they are, the dimensions, but it is 2.5 times bigger, whatever it is. So if you do the ratio of the dimensions, it's 2.5 to 1. So the ratio of the areas is 6.25 to 1 because you had to square the 2.5 and square the 1. So this one is 6.25 times bigger than the original one. So you're thinking that it's only 2.5 times bigger, but it's actually 6.25 times bigger. So you could either times the 13 by 6.25 and you get 81, or you could say, this one was 1 to 2.5, which ended up being 1 to 6.25 when you squared them, equals, they did 13 this year and X next year. So you could just solve that by timesing the two. So it's just like a proportion, but it's just thinking a little bit different. But I did solve the proportion. Okay, so the thing I want you guys to work on is I want you to do number 5. So you have the scale factor of the dimensions of two similar wood floors. So it's not telling you what you're dealing with, area or perimeter, but if you're talking about wood floors, are you dealing with area or perimeter? Area, so you're dealing with area. The scale factor is 4 to 3. So for example, maybe one floor is 400 square feet and the other one's 300 square feet, sorry. One would maybe be 40 long and the other would be 30 long on two sides of the rectangle. It costs $216 for the smaller wood floor. If you pay the same price to refurnish the bigger one, what does it cost to refurnish the bigger one? And then if you get done with that, you can do sticks as well. So I guess the main thing is make sure you square it and make sure when you line it up that you put the 216 with the right thing. So as you go 16 to 9, make sure you put 216 as the smaller one. Make sure you put it that way. So that you guys should get 384. Right? Yep. Oh, you know the rate, the areas, then you can go back and find the scale factor or the perimeters. So right here, if this one wants the scale factor and the ratio of the perimeters, and if it doesn't say, just do the one on the left to the one on the right is what it would usually ask for. So when you look at this one, you have 50 over 98 is the ratio of the areas. You know that's squared. If you can reduce it, that's going to make a huge difference. Because if I try to square this right now, it looks really hard, and I'll have to pull out some things and simplify it. But if I simplify it first and I get 25 over 49, then that's really easy just to square root that. So A to B, this would be the ratio of the perimeters and the scale factor, right? Because they're the same thing. So these perimeters would be, and I can almost see this one. If these happen to be right, isosceles, this would be like 5, 5, 7, 7. Nope, it would be more. It would be twice as big. That didn't work out. That was if it was 25 and 49. So that didn't work. But, and we don't have to say what they are. So that's what you need to do with that. So, let's work on let's have you do ratio of their perimeters, or in other words, find their scale factor if you know this. So
So is the left,
simplify if you can first.
is the left over the right?
Yeah. If it doesn't say, just do left over right. First one over second.
Oh, yeah, yeah.
So don't forget as you do it that once you simplify your fraction, square root it. Yep. To get your answer.
So he gave us a take home.
If you have similar solids, then the thing they have to be similar, they have to be the same shape. So I can't have a pyramid and a prism being similar because they're not even the same shape. And all their corresponding dimensions have to be proportional. So as you look at it, right here, sometimes they'll be flipped and turned. So 3 over 6, 2 over 4 are the smallest two ones, and 3 over 6, those are all equal, so they're similar. So when you come over here, you do 2 over 3, 2 over 3, 3 over 6. They're not the same. Let's look at this one quick. Don't do 6 over 12 for the ratio. You've got to do, the radius is 6. What's the radius of the other one? 5. The height is 12. What's the height for the other one? 10. They're equal. So yes, they're similar. And on this one's flipped, and they're both rectangular prisms. But when I see something like this, I always just look at the first one, and I'll just say, okay, I'm going to do it the first one first, and I'm going to put it in order, 2, 4, 6. So that then when I go over here, I'm going to say, okay, which one would correspond with 2? The smallest one. 6. Which one would correspond with this?
Yeah, same
Why did I say 2, 4, and 6? No wonder you guys are okay, that makes more sense when I'm using my notes. Okay, 4 inches, 6 inches, and 8 inches. So 4 is the smallest one in this one. What's the smallest one in this one? 6. Medium size is 6. And biggest and biggest. Are those all equal? Yeah, they all equal. So the scale factor would be 2 to 3. Right? Let's hurry and find the volume of this so we can just see the volume. Length times width times height, right? The volume of this one is what? 192. And what's the volume of this one? 628. 648. So the ratio of the volumes, smallest to biggest, is this. Or what does that simplify to? Just do it on your calculator if you want to do shots. Math and physics. You guys know how to simplify it fast? I don't even know what it is. 8 over 27 sounded like the So notice this one is 2 over 3. Well, what's 2 cubed? 8, 3 cubed, 27. The ratio of the volumes is going to be the cubes of the scale factor. So if you have, so here's one. This one is 6 and 8. The ratio of these. What's the scale factor of this one? Yes, 1 to 2, right? This one's twice as big. And so the ratio of the volumes should be, you cube it, 1 to 8. And the surface area is like the area, except for it's the surface area. Surface area is 2-dimensional again. So the surface area, this one's 2288, it is the square of the scale factor. So surface area and area are both squares of the scale factor, but volume is cubed. So the ratio is this. And it wants you on this one to do the smaller one and then the bigger one. So we'll put the smaller one on top. These are the volumes, so they're in cubic units. So to get back to the scale factor, you cube root them. And so that would be the scale factor, would be 9 to 11. Let's look at a couple. Okay, quickly do these. You have the volume of both of these. I want the scale factor. And you have the surface area of these, and I want the scale factor. So remember, area is 2-dimensional, volume is 3-dimensional. So you're thinking squared and cubed. And you have to go back to the scale factor and on both of them. Yeah, so this is cubed. So when you cube root it, you get 6 to 7. Now I had a couple people put 36 over 49. 36 over 49 is a helpful information. It's not the scale factor. That would be the ratio of the surface areas. And we're going to go back and forth from volume to surface area in a second, so you know how to do that. This one ended up being what, right here? 4 to 25?
Yeah.
When you simplify it?
Yeah.
So this is, since it's area, it's the square of the scale factor, so it's 2 to 5. So this one, you have 2 cans. The lateral area, which is pretty much just the piece of paper wrapped around it. This is the lateral area, so this is the big one, this is the little one. And it has the lateral area and it's going to volume, so you've got to go from area to volume. So just watch, these ones are ugly numbers, so just watch this one. And we'll do one with better numbers.
We should just try with ugly numbers.
Well, with ugly numbers, the only thing you have to do is you have to just leave it. Okay, quiet guys. This is centimeters squared. This is surface area. So when I do the surface area, this is squared from the scale factor. So you have to square root it. These don't come out to be nice numbers, so I'm just going to leave it right here, square root right here. So that is the scale factor. And then if you want to know the ratio of the volume, you have to go cube to get the volume. So it's just some weird ugly number right here. We'll just ignore that it's ugly for a second. And then we knew that 1157 was the smaller can. So when we set up our proportion, we want to put the smaller can with the smaller volume. And then we cross multiply and solve. So let's do one that's not so ugly. And then I'll have you guys do one down here. This one, the volume is 128 and 250 of 2 similar solids. So how do I go down from here? This is volume, so this is cubed. How do I go to the scale factor? Probably simplify first before I take the cube root, right? So I'm going to simplify and get 64 and 125, which is nice because that's easy to take the cube root of. What is the cube root of 64? And 5. So this is 1-dimensionally, right? Now I want to go back to surface area. So surface area is going to be a squared over b squared, which is 16 over 25. So this is the ratio of the surface area. And I know that the surface area of the larger solid is 250. So where do I put 250? Do I put it with on top or bottom? Bottom, larger, right? And there's the smaller one. I can see that one in my head. That's just 160. And meters squared. So, I want you guys to look at these and I'm going to let you see the answers. See if you can get the answers to 5 and 6. One of them's going one way and one of them's going the other way. This one has surface area. Set it up, find the other volume. And this one is the volume of the larger. This one is surface area. And this is the smaller one. Are you guys just listening? Here is this giant store, and it is the exact shape of a regular times bigger. So the real milk jug is one-dimensionally 1/48 smaller. So their volumes are going to be cubed, right? So if the regular milk jug holds 34 ounces, this one, if you cube 48, you get this much more. It's going to hold this much more milk if you were to fill it up with it. So instead of 34 ounces, you get clear up to 3,760,000 ounces. Let's see if any of these are fun. What's that? Yeah, if I look at this one, it is saying a marble paperweight shaped like this weighs this much. How much does a similarly shaped marble paperweight weigh if it's 3 times as large? So the question here, I think, is you know that the scale factor is 1 to 3, but what in the heck am I doing? Am I dealing with area? Am I dealing with 2 dimensions, 1 dimension, or 3 if I'm doing the weight of it? What would the weight be? Yeah, because it's like volume, right? It's like your weight is like your volume. So this one would be 1 to 9 would be what it would be. And where does the 0.15 go? With the 1, because it's a smaller one. So that's the hard thing in these, I think, with the story problems is do you go to area and do squaring the scale factor or go to 3-dimensional and cube it. So kind of think of what it is, yeah.
Should it be 127?
Yes, 127. I cubed it and then cubed it and didn't get the right number. Thank you. Yeah, so that would be 27 times, it would weigh 27 times as much. Let's just look at this one and see if it's area or volume. You have a cylinder, 4 by 6, diameter 4, height 6, it holds 1 pound of oat milk. The nearest ounce, how much does it weigh? If it is, it's similar in height, but it's 10 inches high. So what's the scale factor on this one? This one's 10 inches high, this one's 6 inches high. What's the scale factor? So like, first off, one-dimensionally, it's just 10 to 6, right? The height, just compare the height. But you've got to think, the nearest ounce, how much will it hold? What's it talking about when it holds something? Volume. So this one would be volume. So you'd have to cube them before you set it up. So, if it's like a window pane, it's area, or carpeting. If it's fence, it's going to just be the same. It'll be one-dimensional. And you just use the normal scale factor. But think of what the problem is to see what you do with the scale factor. If it's area or volume, that's going to be the